Saxon's Calculus, Lesson 12, beginning on page 73, is about the absolute value as a distance, the line as a locus, and then the circle as a locus. So absolute value, if you recall, is in the straight up and down lines, and it means that whatever number is inside always spits out a positive. So if this is 4, the answer is 4. If this is -4, the answer is still 4. And then what they ultimately want to be doing is graphing these. So the thing with a graph with absolute value is that you have both a positive answer and a negative answer that can be spitting out the same thing. So if I have something like x minus 7 is greater than 3, I have to solve it two different ways, a positive way and a negative way. So the positive way is just dropping the absolute value sign and solving it. So then you end up with x is greater than 11. The negative way, and this is just my preferred way, I think the book tends to do it a little touch differently, but I flip the symbol and change the sign on the answer, making it less than -3. So then when I solve, x is less than 4. And then when you're graphing that, you're going greater than the 11 and less than the 4. They're going into opposite directions. So that is the basics that you need for that. Now let's move to example 1. It says graph, and it gives it to me in set notation. X is an element of the reals such that is that straight up and down line. The absolute value of x minus 5 is less than 2, and then they close the set notation, and they want this on a number line, it clarifies. So this is just telling me that any x value I'm choosing is coming out of the reals, and reals is anything I can think of. So we're going to focus on the key part here. It's x minus 5 is less than 2 for the positive version, and x minus 5 is greater than -2 for the negative version. So x is less than 7, and x is greater than 3. And on the number line then, here's our 0, 1, 2, 3, 4, 5, 6, 7. So neither one of them have an equal line, so they're not colored in circles, they're open circles. So on the 3 it's open, and going greater than moves it that way. And then on the 7 it's open, and less than moves it that way. So now I know that I'm connecting my dark line in between the two. Example 2. X is an element of Z. Okay, such that. Now I need to remember what Z stands for, and I'll come back to that. 3x minus 1 greater than 2, close the set notation, put that on a number line. All right, so my Z is the integers, which means I can't do the decimal pieces in between. So I can't put the dots because I don't know where I'm going to be yet. So in other words, if I have a dash here for 0 and a dash here for 1, I won't have any of the decimals in between included because I'm only allowed to plug in the 0, plug in the 1, plug in the 2, and get the answer at that exact spot. So this graph won't have, so if that were happening up here, instead of a solid line, I would have dot, 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 and be done. All right, so now let's solve this absolute value in its two ways. 3x minus 1 is greater than 2, and 3x minus 1 is less than -2. So there's its opposite format. So 3x is greater than 3. I moved the 1 over. X is greater than 1 divided by the 3. 3x is less than -1. I added the 1. X is less than 1/3 divided by the 3. Now I know where I can put my dots. Okay, so here I have a 0. Here is -1, and then this one is 1. Now my problem is this -1/3 is not allowable in my plugging in because it is a fraction in between, and I'm only allowed to plug in integers, 1, -1, yada, yada, yada. All right, so this one is a little touch easier. I don't have the or equal sign, so I know that I can't have an answer at 1. It's open, but I'm going greater than that. So that's things like 2, 3, and so on. So I can put dots at 2 and 3, and I would probably do at least 3 dots before doing an arrow to try to indicate that that dot pattern is continuing. And then I am supposed to be less than the negative 1/3. But again, I can't graph that one. I have to drop to the next one. So negative 1/3 would be here, but I'm dropping to the next integer I can use, which is -1, and I'm going less than that, so to a -2, a -3, and at least 3 dots to establish I feel a pattern, and then I can darken the arrow to indicate that I'm continuing on and on and on. Now, part B is the line as a locus. Locus meaning the same distance, key word there, distance formula. So in example 3, find the equation on the line on which all the points are equally distant from -2, -2, and 4, 3. Now you don't need to do a picture to do this, but just as a quick visual, you're graphing like a 4, 3, and -2, -2. So you're looking for the equation of the line that is somewhere in between them. That's ultimately what you want in like a y equals mx plus b. And we're saying that some point on this line, we're going to call it x and y, this distance matches the same as this distance. And then no matter where I would put that XY dot, that would be taking place, the same distance. That's the locus part of this. So I know that I need to do the distance formula between the XY dot and this 4, 3, and the XY dot and the -2, -2. So the distance formula is, of course, the square root of, and we subtract the x's. So 4 minus -2 is going to be +2. Oh, wait, no, wait, sorry. I'm doing these two distance. I need it with xy. Try again. X, I'll do this one, minus -2, x plus 2 squared plus, and then since I'm still dealing with the y, so y with this one would be +2 squared. Then x minus 4 squared plus y minus 3 squared. There's the two distance formulas, and they are set equal to each other. So if I square both sides, I lose the square roots, and then I need to FOIL out each of these parentheses. X times x is x squared, x times 2 is 2x, doubling to 4x, plus 2 times 2 is 4, plus y squared, plus 2y doubled, 4y plus 4, equals x squared minus 4x doubles -8x plus 16 plus y squared, 3y, -3y doubled, -6y plus 9. Whew, okay, then we need to get that into, oh, did it say a specific, like I wrote into y equals mx plus b over here, but did it say a format? Nope, just equation of the line. All right, so when I looked at their answer, I realized they put it in general form, but we're going to put it in this form because it didn't say which form we had to put it in. So x squareds cancel off on both sides, y squareds cancel off on both sides. Since I want to solve for the y, I'm going to move my y terms over here. So add 6y to 4y, 10y equals, then I'm going to move everything else away. So minus 4x goes with -8x, -12x. The 4 and the 4, so that's 8, moving over, making it -8. And then 16 plus 9, 17. Check my sign on that. Yes. All right, and then divide everything by 10. Y equals -12 over 10. Reduce 6 over 5 with the x, and 17 over 10 isn't going to be reducible. Just a second, I have to try to convert that because they have it in general. Oh, no, that's right. For a split second, I was using the 12 for the y. So, and they also in general form don't want it in fractions. So 10 would multiply with the y, yes. If that one moves over, it would be positive. That would be 12x, yes. And then the minus, yep. So I would accept that as an acceptable answer there. Part C is the circle as a locus. Now, if you're talking about having a dot at the center and the same distance from it, no matter where you go, that is creating the circle. And so the general formula for the circle, which is x squared plus y squared equals the radius squared, that is already the formula for the locus. There's no long distance formula involved here. So they are trying to prove to you that by using the distance formula, however, you get down to this equation. So here in example 4, it says, write the standard form and then the general form, which is the one where it equals 0, of the equation of a circle whose center is 4, -6, 4, -6, and whose radius is 5. All right, so to fill into the basic formula, we're going to do x minus the 4, because we went into a parenthesis squared, plus y minus the -6 is plus 6 squared equals the radius squared, which would be 25. Now that is in its standard form. That was one of the things they asked for. Then it said, put it in general form. So to do that and make it equal to 0, we are going to have to distribute out. So x squared, -4x doubles to -8x plus 16 plus y squared, 6y doubles to 12y plus 36 minus 25 to bring that over and make it equal to 0. So then simplifying it, x squared minus 8x plus y squared plus 12y. And I know I skipped over the 16 because I knew it was a like term to the 36 and then the 25, and I need to put all three of those together. So is that 27? Yes, 27 equals 0. And now that is in its general form. Oops. And that's all it asks for in example 4. Example 5. Write the standard form of the equation of a circle whose diameter is 4√3. So what would its radius be? Half of that, 2√3. And whose center is -4, 2. And it wants the standard form. Okay, so we're going to fill in x minus the -4 is plus 4 squared plus y minus the 2 squared equals this radius squared. And that 2√3 times 2√3, because that's what squared means, is 2 times 2 is 4, and √3 times √3 is a 3, and you multiply those together and you get 12. That's the standard form. Now, example 6. Describe the circle whose equation is x squared plus y squared minus 8x plus 4y plus 17 equals 0. Well, it's in general form, but that doesn't help me describe the circle, because for a circle, I need to know what is its center and what is its radius. So to find the center, I'm going to have to complete the square with the x terms, so I need to put them side by side, and the y terms, I need to put them side by side, and then I need to temporarily move the 17 over and make it negative. So now x squared plus the y squared, and we're going to follow the complete the square steps. Half the x term, -4, squares to 16, add to the other side. Half the y term, 2, squared 4, add to the other side. So that will now equal 3. Okay, so the center of this circle is, pulling out, changing sign, 4 and -2 is the center, and the radius is, and remember that this stood for radius squared, so the radius squared is 3. That means the radius is √3. I was looking for the answer there. Center 4, -2. Yep, that's the pieces we need. And then one more example. Find the equation of the circle whose center is 1, -2, and which is tangent to 5x minus 4y plus 4 equals 0. Now, what I'm picturing here is a circle centered at like 1, -2. So here, and I've got a circle happening. And this equation of this line is tangent to it. I have no idea where it is, but just for visual purposes, touching it in one spot. So I could try to find the spot where the two are touching and use that, just like, what did it want? Find the equation of the circle. Okay, yes. So I would need to then find what that distance is to use as the radius in my format here. However, what I see is that they are using, rather than going through the distance formula steps, they are using that formula that I don't absolutely love, but it works, which is the absolute value of A x plus by plus c all over top of the square root of the a squared plus the b squared. And this one is working as a shortcut for the distance formula when I have an equation of a line. And so because of that being the given piece, it is easier than doing the distance formula. All right, so obviously the number with the x is the a, the number with the y is the b, the non-one is, no letter, is the c one. So we have the absolute value of 5 multiplying with 1, the x value, minus 4. I was debating where I wanted to put that parenthesis, multiplying with the y value of -2, and then adding with the 4, close out the absolute value, over top of the square root of, so 5 squared to 25 and -4 squared to 16. So we've got 5 plus 8 plus 4. Oh, I lost my number here. 17. Okay, so I should have 17 over, and 25 plus 16, 41, square root of 41. Obviously, I can't leave that in the denominator, so we need to fix that. Yeah, I would fix it. So root 41 over root 41, and then I would do that on the calculator and get a number over top of 41. I'll come back to that in a second. Because ultimately it is looking for the equation for the circle, I need to fill it in with x minus 1 squared plus y plus 2 squared equals my radius squared. And so, actually, you know what? I can save that step. I can do it or not do it, because ultimately what I need to do here is square this to fill it into this formula. Either way, when I square the root 41, I get 41 for the denominator, and 17 squared is 289. So there's the equation. So once again, even though I don't love that formula, you can see that when you're dealing with the equation of a line, it is much faster than doing the distance formula that I was doing on the other page between these two and then creating the equation of the circle.